My name is Camilli. I'm a scientist at the Woods Hole Oceanographic Institution. I work in the Department of Applied Ocean Physics and Engineering, and more specifically in the Deep Submergence Laboratory. I'm out here through an NSF-funded program to study dissolved gases within the ocean, particularly gases that have carbon, nitrogen, and oxygen in them. Those three elements are what drive life, and the carbon and oxygen are also, with carbon dioxide, a product of fossil fuel combustion. Another one of those chemicals that's tied in with that group is methane. Methane and carbon dioxide together are biologically active gases, but they're also greenhouse gases. By looking at the levels of these gases, we can tell a little bit about what's going on in the ocean, if there's a source for these gases, or if there's a sink, if there's something that's using them up, or if something is producing them. Right now, there is no good way to measure these gases, methane and carbon dioxide in particular, in the subsurface. We can measure them on the surface with satellites very easily, but there's not much known in the subsurface. And the ocean is the largest reservoir of carbon dioxide for the entire planet. So it's a big, important term, and not much is known about it. And for us to understand climate dynamics, we really need to focus on getting not only better measurements, but more of them. And so this is the first step. What we have here is what's called a Tethys mass spectrometer. But what it is, it's a mass spectrometer that's designed to operate autonomously, and it can operate for long durations, typically of a year or more, if it's provided power. The way that we have it mounted, it's on the bottom of a CTD rosette. We're using it to map the vertical profiles of these chemicals and find out if there are layers in the ocean where the concentration is higher than another layer in the ocean, and then look for correlations. Mass spectrometers are used for a variety of things, everything from space probes to medical diagnostics for blood chemistry analysis. This one is purpose-built for oceanography. It's a little bit unique in terms of its size. In comparison, most other mass spectrometers are the size of an office desk, maybe the size of an entire room. This is the first time it's been deployed from a sailing vessel like this, which is kind of unique. It's, I have to say, very enjoyable. I'm surrounded by a group of enthusiastic students that are interested and inquisitive, and that's always fun to be able to work with the students that are switched on and want to learn something. Then secondly, the ship itself is nice because you're a little bit more in touch with the ocean than you would be if you're on a large ship where you're not subject to the winds and things like that. So it's nice. I'm a sailor. I've kept a boat for close to 20 years now. And some of my friends think I'm a little bit crazy when I come off of a long oceanographic cruise and want to go out sailing on my boat. They say, well, didn't you just come back from being at sea? But it's a little bit different when you're actually sailing.